Hi everyone. Today we will discuss related rates in differential calculus, the third lesson. Related rates compute the rate of changes of two or more variables with respect to time by taking the derivative of the function implicitly. Think of this triangle, the picture. In this picture, if here y and x are variable, okay, which means the picture can be varied maintaining this relation. For example, height is 20 and the small base is 8, and according to the value of y, x can be varied, right? In the case to handle some related rates, always don't forget we must find some equation containing our variable x and y. Okay, I think in this picture we can think the proportion this to this equals this to this, right? Then 22 base 8 plus x equals, if you think a small triangle, y to x, right? Yeah, here. So if you have an equation, simplification is not a big deal, right? By cross multiplying, you can get this one. And if you differentiate both sides with respect to time, you have this type of equation. Now here, dy dt and dx dt are related rates. For example, if the velocity or speed of y was given, then we can find the speed of x. Okay. Now we have some example. A ball is dropped from a height of 20 meters. So ball was here, and the height 20 meters. 12 meters away from the top of a 20-meter lamp post. So this is 12 meters. Yeah, here 12 meters. The ball is ball's shadow. Okay, for example, after some time the ball is moving here. Assume at specific point your ball is here, then your shadow of the ball will be here. Is understandable? So before proceeding, please understand this ball is moving this way, then your shadow of the ball will move this way. Good? Okay. How fast is the shadow moving 1 second after the ball is released? Okay, to solve this equation, we must understand some physical fact. First, acceleration or gravitational acceleration will be, do you remember that? Negative 9.8 meter per second squared, right? And what is the velocity? Velocity is initial velocity minus 9.8 meter per second. Okay, in this case we just release the ball, which means initial velocity is 0, so you can use negative 9.8. I forgot t is here, time. Yeah, time here unit is a meter per second. And the position, I will use the y. Position of the particle will be initial position minus 4.9 t squared. Unit will be just meters. Okay, this is some physics story. But I hope you understand. This is the position, and this is the velocity, and this is acceleration, right? And derivative of this one will be here, and derivative of this one will be here. Is it correct? Okay, now we'll draw another picture. Now this is 20, and ball is here, and ball will move downward, and the distance of this one is 12. Let this is the y, and this is the x. Okay, so from here, the velocity means t y t t will be negative 9.8 t. Is okay? And we want to find how fast is the shadow moving. How fast the shadow moving. So we need to find tx, tt. Good. So we have a two related rates in this picture. So we must find some equation containing x and y. I think in this case the similar triangles will be a wonderful idea. So in a big triangle, height to base must the same. In a small triangle, height and base. Is that okay? Now you can differentiate both sides with respect to time, but I think I want to use the product rule, not quotient rule. So I will modify this one like this: 12y plus xy equals 20x. Is okay? Now I will differentiate both sides with respect to time. Okay? So I hope you can find the derivative actually implicitly. So 12y, so 12 dy dt. Good. Now next one is x times y. Oh, please note that both are variable, so we need product rule. So derivative of the first one is a dx dt, and copy the second one, plus copy the first one, and derivative of the second one, which means dy dt equals derivative of 20x with respect to t will be 20 tx dt. Good. Okay, so here we have this value ty dt. So ty dt here, here, and we want to find the tx dt. I need dx dt here. It appears twice. And can you see that? We need y and x value at that moment. In our question, they said at time equals 1 second after release, right? So when t equals 1, what is the picture? I will try to find some value of y and x at this time. First, when t equals 1, this will be negative 9.8, right? How about y? Y was initial value minus, remember that, 4.9 t squared, which is 15.1 if you plug in 1 instead of t. So if I label this picture, y value is 15.1. Okay, at the time, what is the x? We needed to find the value of x. I will use this one. 12 y plus x y equals 20x, right? So this is 12 times 15.1. If you subtract 15.1x from both sides, you have what is that? 4.9x. Is okay? Now, if you divide both sides by 4.9, x will be 12 times 15.1 divided by 4.9. If my calculation is correct, this is about 37. Okay, so this is a 37. Good. Now we have every information here. dy dt is a negative 9.8, right? Velocity of the ball at that moment, plus dx dt, that is the variable we want to find, times y was 15.1 plus x dy dt, again, equals 20 dx dt. Okay. Now dx dt is here and here. So to combine this one, I will subtract 15.1 dx dt from both sides. Then the other side, you have 20 minus 15.1 will be 4.9 dx dt. Good. The other side, from this, negative 9.8 is the common factor. So if you factor out negative 9.8, now you have 12 plus 37. Good. If you divide both sides by 4.9, then dx dt will be negative 9.8 is 49. And what is that? Good. Wow, look at that. 4.9 and 9.8 is just twice, right? So what is the dx dt? Two times 49 will be negative 98 is a meter per second. Okay. Okay, what is the meaning of a negative number? Remember that? When ball is moving this way, at that moment with a speed of negative 9.8 meter per second, now the shadow of the ball will move this way, because we found dx dt is a negative 98, which means, one sec, the distance of x is decreasing. Is it reasonable? Okay, let me summarize one more time. We may have so many different shapes. For example, if this is a situation, x, y, and z are all variable, then we can make x squared plus y squared equals z squared. If you can differentiate this equation with respect to time, we can find some rates if some other rates are given. Okay? And we already discussed this type of picture already. If this is the data, this is for example A, and this is Y. In the case these two things are variable, then how can you write the equation with the theta and y? I will use tangent theta equals y over A. Again, you can differentiate with respect to time. In our previous picture, this is the variable. Okay. Now, another situation we discussed today. Let this is A, this is B, this is Y, this is X. In this situation, this is the variable and this is the variable. Again, to solve some related rates, we must find the equation containing x and y. I will use the proportion, the height of the big triangle to base of the big triangle equals height of the small triangle to base of the small triangle. Okay? So if you can make an equation, we can proceed, okay, for your next step. Okay. Thank you very much for watching. See you next time. Bye bye.